In this video, we're going to solve a material balance problem with reaction using the DWSIM simulator. So this problem was taken from the Himmelblau textbook, Chemical Engineering Principles and Calculations, 7th edition. So this is problem 12.20 and it goes, toluene reacts with hydrogen to form benzene, but the side reaction occurs in which a byproduct biphenyl is formed. So this is the first reaction where the benzene is formed, and this is the second reaction where the biphenyl is formed. This is biphenyl, not diphenyl. So the process is shown here in this figure. Hydrogen is added to the gas recycle stream to make the ratio of hydrogen to CH4 1:1 before the gas enters the mixture. The ratio of H2 to toluene entering the reactor at G is 4H2 to 1 toluene. The conversion of toluene to benzene on one pass through the reactor is 80%, and the conversion of toluene to the byproduct diphenyl is 8% on the same pass. So calculate the moles of Rg, which is the gas recycle, and moles of Rl, which is the liquid recycle per hour. So for the manual process of solving this, so we should get an answer of about 5.11 pound mole per hour, and for the liquid recycle and for the gas recycle should be 185 pound mole per hour. So to solve this using the DWSIM simulator, first is you have to open the software, then create new wizard, and click next. Then you have to enter all the compounds in the problem. So we have toluene, we have hydrogen, we have benzene, we have biphenyl, and lastly we have methane. Click next. Then for this particular problem, we're going to use a Peng-Robinson property package. Click add the next. Then for the system of units, since here in the problem it uses pound per hour, so should use pound per hour here. So pound per hour, and for the molar flow rate, pound mole per hour. Then finish. So what we're going to do first is create the flow sheet. Sorry, for the entire process. So next is click the material stream. Just have to drag this and click, and I'm going to name this the feed stream. Enter, and this feed stream goes into a mixer. So the mixer is here. You have to use stream mixer, inlet, feed stream, name this mixer, and then have an outlet stream, and the problem, this is gross feed. And this gross feed enters a reactor. So we have a reactor. For this problem, we're going to use a conversion reactor. So just drag, then for the inlet stream, just a crossfade, and click two outlet streams and an energy stream. This will serve as the reactor. There. This is products 1. And this is and since in the problem both products go into the separator, so we're gonna mix both products, and for that we're going to use again a mixer. So I'll have to name this mixer 2, and inlet stream, we have products 1, products 2, then outlet stream, so I'm just gonna pause this so that it doesn't calculate every time we add a unit operation. So call this mixed products, enter, and these mixed products enter a separator. So the separator here, we have compound separator, and since in the problem the separator has 4 outlet streams, while in the simulation only have 2, so what we're going to do is we're going to add another compound separators. So these 3 separators is what the separator in the problem represents. So we're going to connect the mixed products in the inlet stream in the mixed products, then have to add 2 outlet streams and an energy stream. Okay, so to name this our separator 1, this one is for the say mixed products A, and mixed products B, and this mixed products A goes into separator 2, and the mixed products B goes into the separator 3. For the inlet stream to connect mixed products A, and have 2 outlet streams and an energy stream. With this one, just gonna fix this. Okay, this is where the mixed products B, and we have 2 outlet streams again and an energy stream. Don't forget the energy stream, or else your unit operation will not work. Okay, so in the problem, so in the mixed products A, we have benzene 100%, and for the other products we have hydrogen and methane, and for the mixed products B we have toluene and diphenyl. So we're going to name the streams. This one is the benzene stream. Machine enter, and this one is for the CH4 plus H2 stream, and this one is our biphenyl stream, and this one is our toluene stream. So I'm just gonna exit. Okay, so in the problem, this toluene stream is our liquid recycle. So to do that, you have to add a recycle block, which can be found in logical ops. This one, recycle block, and the recycle block, you have to click this and call this recycle, enter, and for the inlet stream we have the toluene stream. Okay, just gonna invert this horizontally. Okay, next is we have an outlet stream. To click this one, connect an outlet stream, and so that the stream will face the other side, you have to invert, okay, horizontally. So this one goes into the mixer, in which the feed stream also goes. So we have to connect to mixer. I'm just gonna fix this to disconnect first, and this we're gonna connect it to inlet stream 5. We have this one. I'm gonna name this liquid recycle, enter. Okay, and for this one, the above stream, in the problem it is split into gas recycle and purge. So to do that, we have to add another unit operation, which is this one, the stream splitter. I have to invert this horizontally, and to invert horizontally also. Okay, so this is our inlet stream. We have CH4 plus H2 stream. I'm gonna call this our splitter, and we have two outlet streams. Just gonna invert this horizontally. Okay, and this one is our problem. This one is our purge. And this one is our gas recycle. So this gas recycle goes into a mixer in which it is mixed with a makeup stream, which it consists of hydrogen, just all hydrogen. So to do that, gonna add the recycle block again, which can be found here, the recycle block. Again, inlet stream is our gas recycle. Just gonna invert this and click this again. Recycle 2 and an outlet stream. Also invert horizontally, and this one we'll call our gas 2. Okay, so this gas recycle enters a mixer. Just gonna invert this horizontally, and we have an inlet stream. Gonna put this in inlet stream 5. You can put it wherever you want. So we're gonna add another stream here in stream 2. You can invert this horizontally. Okay, and this one is our makeup recycle. This is our makeup stream. Enter, and this one is our mixer 3. And we have an outlet stream. Just gonna invert horizontally, and this stream, gonna introduce it into our first mixer. This one, and I will call this makeup plus gas. Enter. Okay, so now we have our flow sheet. So this one is our flow sheet for the material balance problem. So for the specifics, first we have to go to the reaction where we will input these two reactions. So to do that, go to the edit, then simulation settings. We have reactions here. You can see that this next to thermodynamics reactions. Then so to add a chemical reaction, you just have to click here, add chemical reaction or conversion. I'm gonna name this reaction 1. Then we have toluene, we have hydrogen, we have benzene, and we have methane. For our base component, we're going to use the toluene. And for the stoichiometric coefficient, we know that for the reactants it should be negative. Okay, -1 for hydrogen, also -1. For the benzene we have 1, and methane 1, and this phase is in mixture. So for the conversion we have 80% conversion, and click OK. So you can also see the equation here to check if it is correct. So click OK. Then for the second reaction, this one, the side reaction, we have 2 toluene, we have 1 hydrogen, we have 1 biphenyl, and 2 methane. So to do that, click another again, and conversion, name this reaction 2. We have toluene, hydrogen, and this time we have biphenyl and methane, and we're also still gonna use toluene as our base component. We have -2. For the hydrogen, we have -1, we have 1, and this one is 2, and it's also in mixture. And for the conversion, we have 8% conversion. Click OK. Okay, so that's it, and click exit here for the, so here, okay, so it's still calculating. Okay, we have some few errors, but we're gonna fix that. So for the feed stream, we have compounds. So since here in the problem we only have 100% toluene in the feed, so we're going to click the, we're going to change the molar fractions of this to 1 toluene, 0 hydrogen, 0 benzene, top 2 methane. Then step changes. Next is go to stream conditions, and we're going to change the mass flow to 3450 pounds per hour, which is indicated in the problem, 100% toluene. And next is for the separator, since in the problem we only have we have 4 outlet streams, and in our simulation we have 2 outlet streams here. So what we're gonna do first is to separate the products that will then separate in the next separator, just benzene, hydrogen, and methane. So I'm going to separate that here. So to do that, we have to first change this to percent inlet molar flow, and we want the hydrogen, methane, and benzene to enter the outlet stream 1 100%, because it will separate in the next in the separator too. So we have to separate the hydrogen 100%, benzene 100%, and methane 100%. Okay, so these 3 compounds will go now to the stream 1, which is the mixed products in the separator 2, which will then be separated right here in the problem, in which one in this stream we have benzene stream. So the benzene exits at 100%, So to do that, we have to change this again to molar flow rate. Okay. And we want the methane and hydrogen to exit the stream 1 so that the benzene exits the second stream 100%. So we want the hydrogen, enter, and we have the methane, should enter. Okay, and in the mixed products B we have the biphenyl and toluene. So this one, the problem, the biphenyl also exits 100%. So since toluene and biphenyl exits the mixed products B and enters the separator 3, so to separate the biphenyl from the toluene, we're gonna need to do the same. To click this to molar flow rate, and the biphenyl stream will exit 100%. 100% in outlet stream 1. So this separation factor is specified for outlet stream 1, which is the biphenyl stream. Click enter. Then you have to solve this again. Okay, this is still calculating. Okay, we have an error in recycle 2. So we can check that the compound amounts here, we only have hydrogen, benzene, and methane, while in mixed products B, we only have the toluene and biphenyl. And in the benzene stream, we only have the benzene, and for the biphenyl, we only have the biphenyl. And in here, we only have the toluene stream. And in here, we have the hydrogen and methane. So since in our manual process of solving, the gas recycle should exit at 180 pound-mole per hour, and the liquid recycle should exit the gas recycle should enter at 185 pounds-mole per hour, and liquid recycle should enter at 5.11 pound-mole per hour. So have to check the toluene, since in here we have 4,150. Trying to fix the values so that we will attain 5.11 pound-moles per hour. To check this first. Okay. This is 3,450. So to get the 180 pound-mole per hour here in the gas recycle, we have to adjust the splitter, which is a split ratio of 1:0, and we have to adjust this so that I just arranged the flow sheet so that it looks much cleaner this way. So to do this so that the arrow points upward, you just have to rotate this either 190, 180, or 270, and also arrange. And for the gas recycle, so to get 180 pounds mole per hour, we just have to adjust the split ratio to 0.9552 for the stream 1, for this for the purge, and this for the stream 2 is 0.0448, and that way we can attain 185 pound mole per hour, which is close to our manual process solution, which is 185 pound mole per hour. And for the liquid recycle, we have 5.10595, which is also close to our answer, which is 5.11 pound mole per hour. So here, so I think this is it. This is the problem, and we already attained the answer, 5.11 pound mole per hour for the liquid recycle. And for the gas recycle, we have 185.108 pound mole per hour. So I think that's it. Thank you.